I had an opportunity to kind of get a different perspective on things maybe than some, as I kind of had a little unorthodox career path. I started at Lawrence Livermore right out of high school, just answering a switchboard, and gradually moved into more of the engineering areas, and landed in the weapons program as a secretary, and became fascinated by the business and the engineering, and so I decided that I wanted to be an engineer. So I was very lucky in that the people that I worked with within the weapons program were extremely supportive of my education, and were trying to find different projects for me to do that were more technically based to complement the schoolwork that I was doing. So in 1998, I was given a challenge that sort of changed everything for me. So we have, obviously, a lot of the nuclear weapons were designed back in the 60s, 70s, 80s. And so we had a detonator that was manufactured back in the 80s at a facility that no longer exists. Part of the qualification process is it would be armed numerous times, and which would produce a waveform, and there was an algorithm that would go select particular points from that waveform and calculate a series of time and ratio-based metrics. Those metrics were evaluated against an acceptance limit, and it was all just pass-fail. There was no seeing how close to the limits they were. It was just a pass-fail. And that's how they qualified the part. Well, 10 years later, in the mid-90s, mid to late 90s, there was a need to begin manufacturing this component again. And so since the facility no longer existed, we had to find another facility to do this at and re-qualify the process. So we were looking at ways that, is there anything that we could learn from the previous time that we did, and the data, the qualification data, was there anything that we could learn that maybe we might do something differently when we went to manufacture again? So I was given the challenge of, we've got this waveform data that exists only on tape, and all the time and ratio based metrics that had been calculated only existed it was all paper. So I was getting interested in database stuff, so I thought I would learn Oracle and put this data into there and see what could be done. So we were able to extract the waveforms from the tapes, and then I was able to use the point selection software, and all those selected points I put into Oracle and started doing analysis on it. And I don't think that a lot of people really had any idea that what we would find in this. I had one person that was championing it. Oh yeah, that seems like a good project for her. Let's just let her run with it. So as soon as they started seeing how I could query and look for trends, and that there was actually analysis that could be done on that data, I became very, very popular. They were thinking of all different ways that I could cross-cut. And interestingly, and I'm really proud of this, and I think that's sort of why I'm so excited about data, but through the trend analysis and such that I was doing, we actually discovered a small design change that we ended up incorporating that increased our acceptance rate tremendously. So that was when I discovered the power of data. So I will jump in now and give you a little bit of information about what is Lawrence Livermore National Laboratory. We are a nuclear weapon physics and engineering laboratory. We are about 45 miles east of San Francisco. We were established in 1952. It was an old military base. We still have our old barracks buildings that actually my team gets to reside in. They were built in the 60s as temporary structures, and that's where we put our new hires. So we have roughly 7,300 employees, and from the science, technology, and engineering area, we have almost 50% of our staff are PhDs. I am not, but I work with a lot of brilliant people. We have 7.1 million square feet of office space that's on a square mile. We have 684 facilities. Our annual budget is $1.7 billion, and 60% or 63% of that is in support of stockpile stewardship. So LLNL's core mission really is nuclear security. We also have a test facility outside of Livermore, about 15 miles further east, and that's where we do a lot of our high explosive operations. So a lot of the engineers I work with get really excited because boys love to blow things up. So they get to go blow things up out at Site 300. So stockpile stewardship is really cradle to grave. As you think about it, you have this nuclear material contained in there that's half-life is like 1 million years. So we're responsible that forever, I'm sure longer than the world will be around. And it's also a very integrated multidisciplinary program that ensures that we have a reliable nuclear deterrent, but in the absence of actually being able to do any nuclear testing. I love this quote that, and so I'm going to read it. I think it's really powerful and kind of explains the challenges that we have. So, as I said earlier, weapons were designed in the 60s and 70s, and they were really only designed to have a 25 to 30-year lifespan. So if you think about it, we're way, way beyond that at this point. So, and we're not doing any new weapon design. Really, we're stuck with what we have. So imagine that you had a car that was 25 or 30 years old. You'd probably want to get a new one, but you can't. You've got to sustain that car. And by the way, you aren't allowed to start it to see if it works. You're not allowed to test it. But it has to work with 100% reliability when you do, God forbid, ever have to use it. So that's sort of the paradigm that we're in the testing that we're doing and the data that we're collecting. It's how do we sustain our nuclear deterrent without doing any nuclear testing. So we have 3 primary areas of focus. So there's design and manufacturing, and that is from initial design of a weapon system through getting it manufactured, and then as some of our systems were developed back in the 60s, so we've retired those. We've dismantled them, and we're storing the components, or the radiological components. A really big part of our mission is surveillance. So the weapons that we do still have in the stockpile, we bring them in from the field periodically to do some level of disassembly and on them to do both destructive and non-destructive testing. So there's yet another area where we're doing testing and having to capture that data so that we can determine the overall state and health of our stockpile. And then finally, we have for our active systems, there's assessment and certification. So we have to be able to annually qualify with confidence the safety and reliability. So again, there are a whole host of tests that are done that we use to do our annual certification, annual assessment. So our current focus is in life extension programs. And that is in the absence of actually designing anything brand new. So the cradle to grave is concept study all the way to dismantlement and disposition. And phase 6 of that is the weapons that we actually have out in the field that have already been produced. We're maintaining them and evaluating them. We call it our 6X process. So basically, a subset of that is another 1 through 7, where we're doing something, but we're starting with an existing design. So the LEPs are intended to extend the weapon lifetime for an additional 20 to 30 years. So we look for select parts that we can replace or refurbish to meet safety, security, and reliability requirements. And a lot of things have changed since the 70s, so we are able to really leverage some of the more modern technologies, especially for some of our electrical components. We are currently so there's 2 national laboratories that have designed all of the nuclear weapons that we have in our stockpile. One is Lawrence Livermore, the other is Los Alamos National Lab. So our life extension that we're working on here is right now, and this is sort of the impetus for everything that we're doing, is the W80-4. We're just entering into phase 6.3, which is our development engineering. And that's where all the testing starts to occur as we prepare for doing actually our production parts. So this isn't our first LEP. This is the first LEP that we've gone as far as we have with, but from our past LEPs, we know that it generates petabytes of data. And we're spending literally millions of dollars on conducting these tests. And so we should be treating the resultant data as if it's $1 million asset. Unfortunately, our test data from previous LEPs were stored, as most places, especially we're an R&D facility. We're not out to make money. It's sort of all about here and now. So that data was stored in many different file systems. They're each controlled by various groups and individuals with their own data management protocols and priorities. And a lot of that data, unfortunately, was lost or made useless because of hardware and technology obsolescence, personnel changes, or just simply a lack of context. We have all of this data, but we don't know what was done with it or what its pedigree is. So it's almost then useless to us. So why is this so hard? So I finished my degree in 2003, and I came back in, and my mission was I wanted to address our test data and data management challenges. So I went around and I met with a lot of the engineers to better understand what type of data was being generated and what different tests were performed, what context was needed in order to make the data meaningful. So during an LEP, we generate large volumes from multiple sources and in numerous formats. So we do thermal testing, shock, vibration, friction. One I'm going to talk about specifically that we're actually deploying within MarkLogic is our really complicated use case that if we can do this, we can do anything, is the aging and compatibility tests. Our data sets are very unpredictable, highly variable, and really key to our data is that contextual information. We end up doing a lot of post-processing on it, which is very relevant to how you would want to interpret that data later. If post-processing is performed, you want to have those results captured, but still have that source raw data to go with it. And some of our files can be multi-terabyte in size. One of the I can give you an example here. So when we were going through and doing the testing, a lot of times they're just thinking about we need to show that we're meeting this functional requirement. We only need the data today. But what inevitably happens is we do a lot of modeling and simulation, and we run into some anomaly or something unexpected through the process, and they'll go to our analyst and say, can you validate that result that you had? Can you go back to that raw data and see, if we can, how did you come to that determination? Well, if you can't find the raw data, then you don't have anything to show how you came to that result. And we've had to spend weeks hunting down data because it was a really important analysis that we needed to verify, and they had to have the raw data. So because we're R&D, we tend to think very tactically. So my job is to help my management and the mechanical engineers that I work with think more strategically and think about these things that could happen downstream where this data would be invaluable. So these weren't all explored by me. These are actually some explored by me. Others were what people within our program were just doing to try to manage their data. Document management system. We have a document management system and found out that people were pumping in test data in there with some, a little bit of metadata associated to it. But I mean, this document management system owners don't want to house this type of data. I mean, it's multi-terabyte in size, and they have unique storage requirements so that you know how to interpret and analyze that data. This is the big one that this is really how we manage data today, is by file share. We have all these file shares out there. They dump their data in. You can't easily associate any context or metadata. Downstream search and discovery is extremely limited unless you've done some sort of really smart file naming or you have a folder hierarchy that's super self-explanatory. I mean, that data is not going to be able to be found by anybody but the person that put it in there. And I always think of file shares as sort of being temporal storage. I mean, they're really intended for what I said, sharing data, not archiving data. Also looked at some relational database options, but because there's a real lack of predictable heterogeneous data, and it drives continuous schema change, and that's really hard to keep up with. Plus, you can't really store a large file as a blob in your database. You want to have it coupled with the data store to accommodate the larger files. So I decided that I was going to create my own based on the limitations and things that I saw. So in 2003, when I gathered the requirements, I created this prototype web application called the Weapons Test Data Repository. And if you read the description, it's exactly the same description that I have for what we're trying to do in MarkLogic. It was all the very same concept. Unfortunately, I was the only one that really saw the value in all of this, and people thought because I was the developer that I was also the data populator, and I'm like, no, I developed it. You as the test engineers put the data in. But I said there were too many cultural hurdles to overcome back then, so it was never productized. But the concept was well received, and I've always had this in my head. So for this, when David was talking this morning on the keynote, he said there was a customer out there who searched 15 years for a solution. That is me. I searched 15 years for a solution that would match what I had done in my little homegrown application. I said this just wasn't scalable, and I said, obviously, I said one person. But MarkLogic is the first tool that I've come across that met those original requirements. I handed those requirements that I wrote in 2003 over to the development team. I said, here's your starting point, because nothing's changed. The requirements are still the same. And this is MarkLogic in the fact that it can manage these large, sort of unpredictable, non-heterogeneous data sets, and that really aligned with my vision for how we would manage all these diverse sets of data without having a bunch of different data silos. It also offers more functionality than what I was able to do, because we've got a very flexible framework, and things like the data hub that they talked about today are really exciting, because it helps us then aggregate data from data silos to make this more integrated framework of applications without having to do a lot of data migration. So I was going to walk through how we have this deployed. So we have gone with the tiered storage. We purchased initially 500 terabytes. So we have 1 terabyte of flash storage, and that's where we store all of our metadata. And then we have our tier 2 and tier 3, which house the binary collections, where 2 tier is the second tier is really our capacity tier, and then our tier 3 is our archive tier. And what we'd like to do, we haven't done this yet, is have it check for last time data was accessed and be able to do an automatic push to our archive tier after maybe a year or something of not being touched or modified. And let's see. So the team has gone to, so we have some limitations from an authentication standpoint. We're anxiously awaiting OAuth 2 and SAML to be something that's deployed more broadly across our institution, but for now we have LDAP, and so we ran into some challenges in the authentication because we wanted to interface with other applications. But so they built a REST API that's very flexible that interacts with MarkLogic's REST API, and they've created a web front end for doing search, manual import, and doing data collection definition, so defining what that metadata is. The other piece that we were actually surprised at how quickly we could deploy this was to integrate with Tableau. So we're using a concept that MarkLogic has called template-driven extraction to be able to then visualize data from within MarkLogic. We also have this idea of a power user automated data ingestion, so that if someone's savvy enough, and a lot of our engineers are, they can interact directly with the API with some templates that we can provide and modify it to create their own sort of mass ingestion. We'd like to further refine that and have it be more sort of GUI accessible as opposed to having to interface directly with the API. But we do have a lot of people that want to have that level of power and working directly with the API. And our plan, this is future capabilities once we get our authentication, we switch over to SAML. But so here's an example of just one application that we would want to integrate with, and it's ANSYS Granta. It's a materials database. We have a lot of proprietary materials that we want to characterize, and MarkLogic or Granta is actually very good for that. But we also have really, really large files, and so what Granta has is the concept of a data store. So we're replacing their data store with MarkLogic. So we would have, the metadata is stored and indexed in MarkLogic from Granta, so that it would be searchable through our interface. And then once we have the authentication, we want to be able to then have a pointer that will automatically take us to the data source once it's found through the search engine deployed within MarkLogic. So I'll give you guys a case study so you can kind of get an idea of some of the complexity of what we're trying to do. As I said, we kind of picked this material aging and compatibility or multi-material experiment because it really crosses a lot of different areas, and we figured if we could get this use case implemented within MarkLogic, we would be able to accommodate just about anything. As I said, there's a lot of variability in different domains. So one of the things that we want to look at as you think about in a weapon system, you have different materials that are going to be housed next to each other for a really long time. For explosives, polymers, and adhesives are all going to live together, either where they're directly touching one another, or where they're just within this common sort of headspace where there's outgassing that's happening from these various materials that could impact other materials within this headspace. So we're looking at two different things. And we have to sort of simulate the aging process, so we do that through heating. So we create these various test vessels, and within each of them, they basically are, for one particular series, they're all loaded with the same set of materials and parts. And over time, so they'll do a 10-day test to take an outgas sample. Then they'll go 6 months, take another sample, and then they may pull this one from the study and actually disassemble it and start doing testing on the individual components and materials themselves. So you can see we've got component test data, we've got material data, we've got outgassing or gas sample data that all has relationships to one another. So we took a relational view of this to try to understand the relationships and all the various aspects of it. We've got the vessel test itself, which is keeping track of when we're doing the gas sampling and other details. And we've got chromatograph data that we're taking and doing comparisons. We've got the sensor, we have sensor data, we have the component itself, and then so various tests that they're doing on the materials that are part of the component test. So we took that, and using the semantic connections, we're able to create those relationships that we would have created had we put this into a relational database, but it's far more flexible and extensible this way. So just to walk through a simple example, and this is actually some of their test data, is that we have the metadata and the data relationships that can be uploaded in batch. So we upload it through the API, and so the values are defined within the CSV, each row being a value, and then the first row being the field names. So the schema will be created upon ingestion, and it will look to ensure that no matching schema exists. So if there's already a schema that matches those parameters, it will let you know this schema already exists. So now that schema is available in the MarkLogic query console, and then it could be even modified to create other schemas. And then we have an API upload code that executes a post to our API. So we use our standard Python language to turn that CSV into JSON for MarkLogic. And then those records can, once it's in the data, we have our web interface that was created with Angular, and that we can then search through with a link to any related data. So using the semantic relationship, then as you drill in here, you'll be able to see the relationships to other entities. One of the things we were really pleasantly surprised by was the ability to connect to a BI tool. We chose Tableau, and we had the MarkLogic consultant out, and Ben was with us. And within just an hour or so, we were able to get MarkLogic connected we got Tableau connected to MarkLogic, and we were able to kind of create an instant UI because Tableau comes with all the faceting and filtering as part of its standard dashboard. So that, because we were thinking we were going to have to build a lot of that, but by just connecting the BI tool, a lot of the search can be done through this. And so here we've got an example of, we've got these different shots, and they have shot numbers. So we're just looking at one of those shots. So a test engineer could pop this data in and immediately be able to visualize it through Tableau. We could select a second to overlay, and notice that they're offset a little bit on time. So we allow them the capability to make a time adjustment so that you can do a true comparison. And you can continue to add additional shots to this to do comparison. And so this is just one really, really simple example, but it's been really powerful and very easy for us to get that put in place. So MarkLogic's query console allows us to use this template-driven extraction. So Tableau's connected directly to MarkLogic as a data source via the ODBC. And then we're able to then view that through that source code, or view that through the query console. So in summary, we're still maturing a lot of these concepts, but we're really excited about the potential that we've seen. Ben said we've kind of been a customer for a couple of years, but the first year was really more sort of exploratory. We didn't really start doing anything with it until May, June of last year, when we had a team of summer students, and we kind of did a proof of concept and kind of got everything in place. And then from there, we had to order our tiered storage. And so the tiered storage didn't get set up until October. So I think we've made tremendous progress in a really short amount of time, since we really only started deploying it less than a year ago. And I'm really excited about the expanding the framework to take advantage of the data hub technology that was being discussed today. I think that will really help us get to that idea of a single portal into our LEP data. So like I said, we have a lot of other specialized applications. We have our configuration management system being Windchill. We have our materials database. We want to still be able to use those because they manage that type of data really well. We don't want to recreate that within MarkLogic, but we certainly want to have one place where the data discovery occurs. And so through this data hub, we can provide that single point of entry and data discovery across our numerous data sources. So I'm actually really anxious to hopefully come back next year and share our progress. I said I think we're going to be getting a lot of new use cases incorporated into this tool at that time. So I'll be anxious to come back and talk to you all about it. Yes. Yes.
I'll start. Could you talk about the curation process? Because it seems like with so many different data models and data sources, it would be hard to align things. Can you speak to how that works for you guys?
So there's a couple of things that I think are going to be really key for us to establish and that we're working on in parallel to doing this. And part of that is our governance, how we're going to manage data governance. And also a part of that is the pedigree and provenance of the data and how that gets curated. And I'm not sure that we've worked through all of those things. I said I think we have a pretty good idea what we're doing in the security space. But one of our, we don't have, let's try to think of how to word this correctly. There's not a lot of change in things that occur. So in capturing, the key for us is really capturing the core information when the test data was created and being able to associate the contextual data. The contextual data provides a lot of that sort of data curation detail. And as additional analysis or post-processing, we want to establish a mechanism for notifying people of the quality of the data and their confidence in the data, that this is raw data that's never been looked at, or this has been processed and we have 50% confidence that this is our final. So we've got some. There are other areas that have a matrix for data quality and characterizing data quality that we want to incorporate into this, so that people have some idea of what their confidence level should be and how mature that data is, or I said if it's just really raw data that you don't want to put too much stock into. Yes?
Do you mostly deal with the structured data, or you also deal with the documents?
So do we deal, the question was, do we primarily deal in structured data or unstructured documents? Both. I mean, that's sort of that unpredictable, non-heterogeneous. We have to be able to accommodate. Structured data is easy. Unstructured data is a little bit harder. So that's sort of why we went in this direction, is I think MarkLogic allows us to sort of synthesize that. And we can store the structured data, we can index whatever we would want to index. Or if we had a document, we could index that for a full content search. But there's a lot of our unstructured data. One of the big use cases that we also have is our CT image data. So one of the things, I'll get into a little story, so I hope you don't mind. So we have, to see that the sort of the nuclear component, the high explosive, the only way that we can do evaluation on that is through CT imaging, because we're not going to take it apart to that level. So we do the CT imaging, and we have some very robust visualization tools that we use to go in and characterize that and identify flaws or defects or whatever they would want to capture. So what we're planning to do, we actually have done some of this already, is we're going to have the metadata associated with the CT image, but the CT image is unstructured data, but we have the visualization or the analysis that's done on it, and we would want to capture those defects as structured data. So MarkLogic provides us the capability to be flexible enough to sort of capture all that within one system. So yeah, I mean, that's really the beauty of it, is the structured and unstructured potential.
I was wondering, are you using the alert mechanism provided with MarkLogic?
Pardon me?
Alerts, like for example, if you see the specific pattern of the text data.
Oh, you're asking if we're incorporating machine learning type stuff.
Yeah, machine learning or alerts.
I think that's one of the potentials that the folks doing the material aging and compatibility study, they would love for us to be able to start applying machine learning to that data once we have enough data in there that could be done, is to look for exactly what you're talking about, is start learning what you would expect to see, and be able to provide an alert if you see something that's varies from that. So I think that's why it's exciting to hear some of the things they're doing in machine learning. And I have a couple folks on my team studying machine learning in graduate school, and so said that people are excited to have this data available that we could apply those types of tools to.
Yes, can you explain more in detail why you had to work out the metadata portion of that?
I'm not sure I understand the question.
So in your diagram you had the was like working with rectangle and you had metadata. I don't know if the metadata was from structured or unstructured.
Oh, let me go back to this. Was this my diagram?
Yes, at the bottom left.
This here?
Yes. Left.
Bottom left. Oh, here. Oh, I gotcha. Okay. And so ask your question again. Now I'm tracking on what we're talking about.
Can you explain more in detail why you had to do that? I'm sorry. Yeah, can you explain more in detail why you had to kind of work out the metadata portion of that? Was that not a capability that was available in MarkLogic?
So what we're doing is we're actually, I said we hope to do this through the data hub, but for now the plan is to have the metadata. There's already metadata that is, for example, this material characterization, material property data. So you would have your material of interest and a couple of other key parameters that, and then a whole lot of other material test information associated that's stored within Granta. But we would want someone who's doing a material aging and compatibility. Let's say one of the materials they have is a material that's very richly characterized within Granta. So we would want to pass that a few key parameters to have them be available through MarkLogic for discovery purposes. But there would be a pointer back. If you had the right need to know or right access, you could get back to the data in its host system. We have a lot of data in here. Don't want to replicate it all into MarkLogic. It's really utilizing, I always thought there's no silver bullet. I think MarkLogic provides a silver bullet from an ability to bring together data silos. But we're never going to get rid of these specialized applications that we have, but we want to make sure that that data is discoverable. So by selecting key metadata that we would want to have stored in MarkLogic and indexed allows us to still maintain these other data sources. Did that answer your question?
Yes.
Okay.
What would be your recommendation someone having to ingest paper data to do the step you initiated during your experience doing
Oh, with that, that's a good question. So the question was, how would you ingest paper data? So what I ended up having to do with the other is actually going back to the raw data, right, and then recreating the data that was captured on paper. So we were fortunate that we still had the raw data and we knew the algorithms that they used to do the point selection and calculate the metrics. But I don't know how we would have been. I mean, I'm really leery about the OCR kinds of things. It takes a lot of work. There are some that you can train and they're pretty smart, and we've done that with some of what we call we have our BOM books. So it's a whole bill of material for the record of assembly for the BOM, and a lot of it's on paper. It's scanned on microfiche, and so we have used that OCR software before to establish some key metadata that at least people will be able to go and find things within the paper. And so we would be able to extract that and put that into MarkLogic. But yeah, I don't know. I said we were fortunate that we had the raw data and enough information about how to recreate that subset of data.
How are your users, right? How are they consuming the data? Do you expect all the users to speak SQL or?
No, gosh, no. So I said that's a bit. So one of the things that I've learned over the years is, I think your data generation use cases are just as important as your consumption use cases, right? It's understanding how that information is going to be used, not just by sort of the obvious immediately people, but what are other downstream consumption use cases and how would they want to be able to access that. And so we're putting a big focus on that front-end UI. For a power user that wanted to go and interact directly with our API, we can do that. But over time, we want to build, make it very simple for the non-techie people to have a user interface that they could go in and I said we have this web interface that we've built for the search and retrieval of data.
So are there any efforts to do the ontology-based kind of data access?
I would love to have an ontologist on staff. I think that it's hard. I work with, I joke, because the name of our division is Defense Technologies. I call it Dinosaur Technologies. I have to take them in baby steps. They said getting them to get rid of their Excel spreadsheets and paper and file shares has been really, really challenging. So what you're talking about is really next level for them. But this is, so this is really, we're reeling them in slowly on it, but being able to have an ontologist on staff to really help would be fantastic. Yeah.
So that REST API that sits dead in the center, that is something you at the laboratory and the rest of the team ultimately came up with, like a custom API to talk to the MarkLogic API and stuff?
Yes.
And then also the web front end for uploading and inserting files and stuff like that?
Yes.
That was also just handmade?
Correct. Well, I don't know, if one of you want to talk, Sam can maybe talk to that really quick on the concept.
This is true, yes.
So I have a team of Python folks too, and so and actually we have a lot of Python is big for us at Lawrence Livermore, and so we're doing things a lot where they're Python based. So we have a lot of Python developers. So.
Another question?
Sure.
So in one of the slides, you mentioned that you're going to actually generate new schema based on the data. Is that correct?
Yeah, I think that's the beauty of MarkLogic is you don't have to have your full schema defined. I mean, with the relational databases, they talked about in the keynote this morning, is you kind of have to have all those relationships established within your. You said when you talked about the poster of an entity relationship diagram, I have one of those in my office, and I said they're very difficult to go in and add new relationships to later, but with MarkLogic and sort of their multi-model and semantic setup, it's very easy to go back in and establish those relationships at any time. You don't have to know those relationships up front.
So I'm just wondering how, if there may be multiple, or potentially many different schemas, how do you manage them or impose some governance?
So, did you want to say something, Sam?
It's a really hard question to answer.
Yeah. That's all part. Yeah, the data governance is tricky, and so we were trying to figure out at what level do you tag information to determine access levels, right? So we're really trying to. We have a lot of very strict, being that we're in a classified environment, right? You need to know rules, so that is paramount to moving this forward. So we're still working that part out. That's why we're kind of starting with a single use case to really figure out how we want to partition data for bringing in other use cases. But that's a very critical element to what we're doing, is establishing the appropriate governance and how we implement that governance. Okay. Well, I think we're right up on the time.
Yep, we just have a couple more minutes if someone has a question. If not, next would be lunch. Any more questions?
All right. Thank you all.